Hi guys, we all know that music is made of sound and sound is made of waves and waves is part of physics and physics is just expressed by math. So today what we're going to do is we're going to be exploring some of the math behind music. People, my name is Mr. Teo and I'm the Science Academy's physics and math expert. I don't know if you remember from music classes in school that we have a total of 8 notes in the standard Western major scale. Now, this makes up for 7 intervals. So for those of you who cannot remember, of course we have Do, Re, Mi, Fa, Sol, La, Ti, Do. 8 notes with 7 intervals in between. But for those of you who study music, you will remember that this isn't the complete picture. In reality, there are 5 additional notes, which makes up for 13 notes in total with 12 intervals in between. So if you look at the piano, you'll notice a total of 12 intervals before the pattern of keys start repeating itself again. Alright, this includes both black and white keys on the piano. So if you go from one note to the next similar key up or down the keyboard, basically this is what in music terminology we call an octave. For those of you unfamiliar with music terminology, basically we are going from one note to the next note. Do, do, do. Now, in O-level physics, we learned that the pitch of the sound corresponds to the frequency. In other words, how many times the instrument causes the surrounding air to vibrate every second. So it turns out to go from one octave to the other, the frequency of sound is always double, meaning it multiplies by a factor of 2. And since double the amount of vibrations are made, this makes intuitive sense because if both the waves are produced together, they will both start and finish together after a whole number of cycles. But what about the intervals in between? What is the factor by which we should multiply a particular frequency in order to get to the next higher interval? So let's do some math. So let's let our current frequency be f, and the next higher interval is going to be f times r. So we know that since there are 12 intervals, if we want to go all the way up to the next higher octave, we need to keep multiplying by r 12 times. So in total, this is going to give me r to the power of 12 times f is equal to 2f. Since one octave up is double the frequency. Now, cancelling the f and solving for r, you realize that r is just going to be the 12th root of 2. This is somewhere around 1.05946. So for example, if we take this key over here and we insist that key is 440 Hz, then the next black key higher up is going to be 440 times the 12th root of 2, which gives us somewhere around 466 Hz. So this subdivision of frequencies is actually used for tuning most modern instruments, and this method of tuning is what in the music world we call equal temperament tuning. So ladies and gentlemen, why don't you pick up a musical instrument and make some music? Curious minds, everyday discoveries.